Statistical quality control, and this is chapter 6 of the book. And total quality management was chapter 7 in this book, but we have gone through the chapter from the Stevenson's book. But this book is much easier than Stevenson's one to understand statistical quality control. Is it recording?
Yes, sir.
Yes, sir.
Yes, sir. Yes, okay, that's fine. So statistical quality control, as the name states, that it is quality control and quality control through statistical tools. Say for example, you will calculate the average and then the standard deviations. What is the standard deviations of the average? We can calculate the average and standard deviations to know the outliers or anything going beyond the standard deviations. And you know what is standard deviations and what is average. Standard deviation means the deviation from the average. If we cite an example of standard deviation, and we have already cited, if you can remember. If I want to know the average age of the students, undergrad students of North-South University, if we want to know the average age of the undergrad students of NSU, what we have to do, we have to take a sample. Say for example, I can take the sample of my class. And after taking the class as the sample, I can easily calculate the average. That is the average age of the total university for the undergraduate students. But the problem is that your age is 21, but someone age is 24, someone age is 18, say for example. So there are some deviations. What is the standard deviation? We can also calculate the standard deviation, and standard deviation usually we calculate plus minus. Say for example, 21 is the average age of my class, and the standard deviation is 3 plus minus 3. That means someone is 18 and someone is 24. These are used as the standard deviation in quality control in the organizations. They produce the product and take the products from the total output as samples, and they test the samples. What is the average fault, say for an example, and then they check the standard deviations. Yes,
Sir, standard deviation টা কি স্যার বুঝলাম না, মানে এখানে প্রোডাকশনের সাথে কেমনে কি গেল?
what's your name?
Sir, Afdalin.
Oh, you're Mr. Abdalin.
Yes, sir.
Okay, I will explain it once again, but for the moment I am just giving you the idea of what is standard deviation. Is it not clear that average age of the classroom is 21 and
Yes.
someone is 3 years older than you, someone is 3 years younger than you?
Yes, sir.
And this 3 years plus minus
Yes,
3 years is known as standard deviation. Plus minus 3
Okay.
years is known as standard deviation. Is clear?
Right, sir.
So average age of your classroom is 21, and
Right.
this is the sample average, and we can say the average age of the undergrad students of NSU. NSU is now the population. Sample is taken from the population. Population is not humans, Janogon, Janosankha. Population means the area, the total area from where we have taken the sample. So NSA is the all students of NSA's population, and your class is known as the sample. So after calculating the average from your class, we can say that the average age of the undergrad students of NSU. So from the sample, we are inferring on the total population. And then standard deviation means average age of the total students of NSU is 21 undergrad students, and standard deviation is 3. Someone is more than 3 years, someone is less than 3 years, plus minus 3. It is the standard deviation. Sometimes some students are older than 3 or younger than 3. So these are the exceptional cases. And if the exceptional cases are too many, then the university authority have to redefine it, rethink it to control the average age of the students. Now let's apply it to the organizational culture. You are producing garments. And you are shaping the garments. You need to know what is the defects, what is the average defects in the total production or in the total lot. What you will do? Will you test all the population, all the garments, or you will just test some samples? So you will take some samples randomly from the total output, and then you will check the quality. You will then calculate the average. What is the average fault, or what is the average defects? And then you also calculate the standard deviation. What is the standard deviation of the defects? Standard deviation of the sample. And based on the standard deviation, you can say that the average fault is 2 pieces per 1000, and the standard deviation is plus minus 1. Say for an example, plus minus 1. It means that your average fault is 2 and maximum is 3 and minimum, if standard deviation is 1, maximum is 3 and minimum is 1. So you can use this standard deviation to know the deviations from the average. These tools are used by the quality control managers in all organizations. And if we say that 2 is the average and plus 1 is the upper limit, and 2 is the average minus 1 is the lower limit. So you can say that upper control limit and lower control limit in relation with the average. Okay, if you do not get anything and then I am showing the issues, this will be clear. This is all about today's lecture. Today we this chapter's lecture. That means we are calculating the average and also the standard deviation. And then we can conclude that in a factory, it is the standard deviation and the average picture and the standard deviations and the product output or the quality will be similarly matched with the calculations, or we are inferring on the populations based on sample. So statistical quality control, look at the slides. Statistical quality control, the term used to describe the set of statistical tools used by quality professionals. Statistical quality control encompasses 3 broad categories. Number 1 is Descriptive statistics. Descriptive statistics means that you need to calculate mean, standard deviation, and range. Do you know what is range?
Sir, maximum value minus
Highest
minimum
minus
value.
lowest.
Good. So, is there a relationship between range and standard deviation?
Yes, sir. So
Sir,
from the
range
range we can
parameter
expect.
is the key standard deviation, like the highest and lowest the key standard deviation.
Standard deviation is not the difference between highest and the lowest, but ultimately the range and standard deviation is almost similar, isn't it?
Yes, sir. Sir, what I meant to
Almost.
say is like the highest parameter.
Yes, so highest minus lowest is the range. So standard deviation and range is somewhat related because we are calculating the deviation from the mean. Mean means average. We are deviating from the mean. So standard deviation means deviation from the mean average. Our class size is 21 years on average mean and plus minus 3. Plus minus 3, it means that the highest age in the classroom is 21 plus 3 equals 24 and lowest class size is 21 minus 3 equals 18, isn't it? So highest age of the classroom is 24 and lowest is 18. And the difference is the standard deviation, is it? Highest and lowest difference is 8, is it? Oh, not 8, 4, 6.
6.
6. So it is almost similar to standard deviation. That's why sometimes many quality control managers use range as the indicator of standard deviation. Standard deviation, difference between highest and lowest. So range and standard deviation is somewhat related, but it is not totally same. So we are coming. We will apply both the methods, average and also the range and also the standard deviation to calculate the quality control limits. So statistics or descriptive statistics means average, standard deviation, and range, and statistical process controls. We also apply statistical process control tools. Statistical process control means calculating average, and then upper limit. This is the upper limit and the lower limit. Three limits use, and we use through standard deviation and also using range. So standard statistical process control will apply here, and then acceptance sampling. What is acceptance sampling? That I was talking. Population is the total garments production. Population is the total garments production. But you cannot test all the garments. So what you will do, you will take a sample, and based on the sample, if everything is within our calculation, within our standard deviation, then you will decide that all the products are good and acceptable. It is known as acceptance sampling. Or based on that calculation, we will decline that, or you will reject that the product are not qualityful. You can say it is known as the acceptance sampling, used to randomly inspect a batch of goods to determine whether the batch is acceptable or not acceptable. This is known as the acceptance sampling. So get just the idea, then we can discuss more details in the coming slide. what happens? Oh, yes, here. So what I am talking that average or mean is known as the central line. Mean is known as the center line. Central line. The mean, the measurement of mean, this is the formula. I don't think that nobody knows it. I think everybody knows the definition. This measurement of central tendency or the mean or the average. Average is usually referred to as x bar equals summation over total x divided by number of observations n. And range is the difference between highest and lowest value. Is not given here the formula. Highest minus lowest is the range, and standard deviation related to this x bar average xi means xi 1 2 3 4 5 xi minus x bar square divided by n minus 1, or sometimes n is enough. If you use n, there is no problem, and multiply it is known as the standard deviation. Root over of xi minus x bar whole square divided by n minus 1 is the definition of standard deviation. So in your classroom case, how can you calculate standard deviation? That means average means I have calculated the age of yours says Mr. Abdullah's age, Mr. Abdulin says, Mr. we have added all the candidates or the students age, and then we divided by total number of students. As per the record today is 31 divided by 31. Then we will get the average and standard deviation. Maybe Abdullah's boys is age is 25. So 25 minus x bar. X bar means if the average age we get is 21, then 25 minus 21. Plus then second one maybe Abrar is 20 minus 21. So in such a way we can calculate all the differences with the sample, and then we can get the standard deviation. And distribution of data shape, it is also the statistical issues. These are all the statistical issues. Distribution of data shape, whether the distribution is normal or abnormal. Normal and abnormal, what is it? Say for an example, our standard deviation here, standard deviation is plus minus 3 is the standard deviation. 3 sigma is 3. It means that 50% of the students' age will be around minus, and 50% will be around plus. 50% will be plus. Then you can get the normal shape age and relationship age, and undergraduate. If it is normal, then this will be like this. That means your 50% will fall in this area, rest 50% will fall in this area. Usually we deal only with normal distribution. Bell shaped or skewed. Skewed means maybe 75% is minus and only 25% is plus. That means this 3 plus 3 is applicable for only 25%, and minus 3 is applicable for 75%. This is known as skewed skewed
Sir,
distribution.
right skewed and left skewed. ওটা।
Maybe right or maybe left, or sometimes it is known as maybe positive skewed or maybe negatively skewed. This is not important, but for your understanding and for your reference, remembrance, if you can remember your, you know, previous statistics course materials, this distribution or probability distribution is discussed there.
Sir,
In
do we have to
details.
memorize the formulas?
Yes, you need to memorize the formula, because this formula is so basic formula, and without this formula it is not possible to lead your personal life. Even
Oh,
you cannot lead your personal life. When you will go to shopping, then you have to calculate how much you will spend on average to buy a shirt. And when you are going with your girlfriend, then you have to take care that how much on average you are spending to buy different items. These are all very important on average calculation.
yes, sir. And standard deviation, sir?
Standard deviation is also very important. Although it is important for your
Sir, average টা তো স্যার বুঝি স্যার, স্ট্যান্ডার্ড ডেভিয়েশনটা না স্যার একটু প্রবলেম।
কেন বুঝলেন না কেন? সমস্যা কি হলো? বললাম ক্লাসের মধ্যে কি বললাম যে আপনার বয়স কত?
ওই
25।
পার্টটা বুঝছি স্যার, এই যে ফর্মুলাটা, এই যে এক্সআইটা কি স্যার, আর এই যে
এক্সআই হচ্ছে
এক্স
যে এই
বারটা
যে
তো
আমরা বললাম যে প্রত্যেকের এইজ, যেমন আপনার এইজ ধরলাম 21 -21, there is no
ও
standard
মাইনাস দ্য অ্যাভারেজ। ওকে,
তারপর হলো যে মানে আপনার বন্ধুর এজ 25 -21, তাহলে কত হলো? 3।
4 স্যার, 25 এর থেকে 21 গেল।
Maybe if it is okay, I'm coming on that point. So maybe 24, because our standard deviation we say that it is 3. So you
Right,
are
right.
gonna calculating the standard deviation, the very simple system. From the observations, you will just deduct the average that you have calculated here, and then you will divide by 1. And why you have used the square? Because someone will be minus, someone will be plus. To
Okay,
neutralize the minus and plus, কারণ আপনার
right.
কথা বললাম, একজনের কথা বললাম কি 18, একজনের বয়স 18, 18 minus 21 is, what is the value? Minus 3, 9,
Yes, sir.
minus 6, নাকি
না স্যার,
minus 3.
3 হবে, হ্যাঁ।
So minus 3, when you will use plus minus, there will be problem of sign. Maybe the standard deviation will be -5, -3 or
Correct, sir.
-5. We can neutralize by using the square sign. All right.
Yes. All right.
Okay. So
Thank you.
calculation of standard deviation means what is the difference with the average? So
Right.
this is also very important for your life and also for normal calculations.
Definitely.
And then control chart. We are going to develop control chart. This is the average line. This is the upper limit. Average line in your classroom is 21. The average line in your classroom is 21 and plus 3. Upper control limit. This is known as upper control limit. Upper control limit in your case is 21 plus 3 plus 24. Upper control limit, and lower control limit 21 minus 3 equals 18. Have you got it? What is upper control limit and what is lower control limit, and what is central line or control limit? Central line. This is also known as center line or control limit. No problem. You can use both the words.
স্যার,
So,
এটা কি স্যার ওই যে কন্ট্রোল লাইনটা স্যার মিন হিসেবে কাজ করছে, যে
average. 21
Average.
your class size, classroom is
আর প্লাস
Average.
-6 যেটা ছিল ওইটা 3 যেটা ছিল।
Standard deviation. Standard deviation.
গট ইট স্যার।
Okay. So
Okay, sir.
now the question is, one of the students' age is 25. One of the students' age is 25. So observation in control system in the organizational life, this is known as the out of control or outlier. Out of control observations. So your average, maybe your average defect rate is 20%. That is true with standard deviation of 1. That means 3 is the upper limit and 1 is the lower limit. But sometimes it happens that the average, you know, sorry, not the average, one of the observation or one of the observations in the sample is more than 3, maybe 5, 4 or 4% defect. Is it impossible to happen in the organizational life, in the organizational culture, in production operations? You have taken a sample from a lot and you have find that in one sample, one of the observation or one sample has 4% defect and other are within the control, plus minus 1. Plus minus 1, 2 plus minus 1, what does it mean? Who can tell me?
Sir, minus, sir, 1 to 3.
1 to 3, range is 1 to 3. Okay, we are coming back if you do not get the idea. I think you have got the idea what is the central line headed one, what is the upper control limit and what is the lower control limit. Usually organizations set these lines and they check whether their production is within the limit. If something is out of the limit, then the management takes extra care. Why my observation or why my defect rate is more than my control limit? The management, operations manager or quality control manager takes extra care of this value, out of control or outlier observation. And this is the signal that some abnormal operations are happening there in the factory. So control chart is for two types of issues. One is control chart for variables and another is control charts for attributes. Control charts for variable are used to monitor the characteristics that can be measured. That means your age can be measured, isn't it? Your height can be measured. Length, weight, diameter, time. These are the variables. You can use formula for variables, separate formula for control chart for variables. You can use control charts for attributes. Attributes are used to monitor characteristics and that have discrete values. So here is, you know, to monitor the characteristics that can be measured and it is discrete values 1, 2, 3, etc. and can be counted. Say for example, percentage of defect. So the example I have cited here is about attributes, percentage of defect, flows in a chart, etc. So we can use control chart for the examples. The next examples will make it more clear when you will apply control chart for variables and control chart for attributes. Attributes means discrete values and that can be counted and usually it is measured and there is a range. Control chart for variables. Now we are discussing about the control chart for variables. For developing control charts for variables, use X bar chart and R bar chart. X bar chart means average chart and R bar chart means it is the range chart. We'll calculate the range. Say for an example, come to this, example. These are the observations and these are the samples. Sample number 1, you have taken 3 different samples. You have taken 3 different samples from the population. So sample means you are taking some garments from the all garments. You cannot test, you cannot check all the garments. What you can do, you can check some samples. You have taken here 3 samples, and in each sample, this sample 1, you have taken 4 observations, and what happens to here? Constructing an X bar chart. A quality control inspector at the cocoa fish soft drink company has taken 3 samples, 1, 2, and 3. 3 samples with 4 observations. In each sample, there are 4 observations. Each of the volume of bottles filled. These are the bottle fills, soft drink. If the standard deviation of the bottling operation is 2, maybe the standard deviation has already been calculated by the management of the company. They always think that this is the perfect standard deviations, and use the below data to develop control charts. So you are gonna developing control charts with limits of 3 standard deviation for 16 ounce. This 3 standard deviation means this is the normal 6 sigma calculation. In normal distribution, if you use 3 sigma, it covers around 99% or 99.74%. So we usually use 3 sigma, you can use 2 sigma, but here in our problem we have used 3 sigma standard deviations for 16 ounce bottling operation. So develop the central line and the control limits. The average of sample 1 X bar, average of sample 2 X bar 2, average of sample 3 X bar 3. This is the sample averages. These are the observations, and the sample range. Here the range is 0.2 because the highest value is 16 and the lowest value is 15.8. The difference is 0.2. Here for sample 2, the highest value is 16 and the lowest value is 15.16. Highest value is 16.1. 16.1 and the lowest value is 15.8. So 0.3 range. In sample 4, the highest value is 16 and the lowest value is 15.8. That means 0.2. So we have developed X bar here, and we have applied X bar using simple mean sum of these 4 components divided by 4. All right. 15.8, 16, 15.8, 15.9. We sum up these 4 observations and we have divided by n is known as, and here it says k. This number 1, 2, 3, 4. This it says k. It says k because number of observations and number of samples, 2 different issues. So here they say that number of sample is n. 1, 2, 3. In value of n is 3 and value of k 1, 2, 3, 4. Value of k is 4. So you can use this formula to calculate the standard deviation and also the average of different samples. Here k is the number of, in the k is the number of sample means Number of sample means 1, 2, and 3. 1, 2, and 3. K. K means because it is double bar. X double bar. So X bar is average of the sample and double bar is average of the sample averages. Sample averages. X1, X2, X3 means 15, 15, and 15. These three figures. And divided by this will also be K. So there is also formula problem. This N should be K divided by K, 1, 2, and 3. And standard deviation of the samples you can calculate by standard deviation. This is the population standard deviation that usually is described here, divided by root over n. This n means n. N is the number of observations. So here the number of observations n within each sample. So upper control limit is plus and lower control limit is minus. As like the students, this is the average age of the student 21, this is 3, and this is minus 3, plus 3, minus 3. But here we use Z value. Z value is here, the 3 standard deviations. And okay, calculations are given here. Calculations are given here. The average X double bar central line is 15.92. In the control line, it is this line is the average of the sample averages. Average of the sample averages. This is the number 1 samples average. This is the number 2 samples average. This is the number 3 samples average divided by 3. And the average sample mean is 15.92. Average sample mean is 15.92. It is the central line. And the control limits for 3 sigma. 3 sigma, why 3 sigma? Because we have already described that the chart with limits of 3 standard deviations. So 3 standard deviations we're gonna count. This X double bar is coming from here, 92, plus 3 is coming from the information that we have declared that within the control limit 6 sigma. 3 plus and 3 minus, total 6 sigma. Within 6 sigma, our all the problems are counted. Standard deviations are within 3 sigma. And the upper control limit plus, and this 0.2. 0.2 is from population standard deviation given there in the information. We also give you this information, 0.2. 0.2 ounces, 0.2 divided by root over 4 equals 16.22. The same thing here, you are inferring on the population and you have taken some sample. আমাদের যে আগের যে ক্লাসরুম এক্সাম্পলটা ছিল, ক্লাসরুম এক্সাম্পলে কিন্তু আমরা শুধুমাত্র আমাদের ক্লাসকেই স্যাম্পল সাইজ বলেছি। তাতে কি আপনি মনে করেন যে টোটাল বিশ্ববিদ্যালয়ের পিকচারটা পাবেন, স্ট্যান্ডার্ড ডেভিয়েশন পাবেন? মনে করেন পাবেন না। এই কারণে কি করছি আমরা এখানে 3টা স্যাম্পল নিয়েছি। একটা হলো আপনাদের ক্লাসরুম, আরেকটা অপারেশনস ম্যানেজমেন্ট নিল, আরেকটা হলো কম্পিউটার সায়েন্সের একটা স্যাম্পল নিছে, আরেকটা স্যাম্পল নিছে আপনার ধরেন ইলেকট্রিক্যাল ইঞ্জিনিয়ারিং এর। তাহলে কি হবে যে আপনি একটা accurate result পাবেন। For the whole university you are taking 3 sample, 3 classroom. So you are just calculating the average of the 3 classroom, and this is the system of calculating average of the 3 classroom, and then you can define the upper control limit X double bar, that means average of the sample averages. এটা হলো কি আপনার ক্লাসের এভারেজ 21, তারপর হলো আপনার সিএস এর 20, আর হলো আপনার আরেকটা ক্লাসরুমের ধরেন 22. There is the average of the sample averages, and Z or Z means the establish, 6 sigma measurement. 3 plus minus 3, that means 6. 3 plus 3 minus 6 sigma. And 6 sigma is known as 3 sigma. Plus minus 3 sigma limit. So 3, and you are calculating the sample standard deviation. 0.2 is the population standard deviation. You are dividing the population standard deviation by root over 4. 4 means it is the number of observations. And the upper control limit is 16.22. And the lower control limit, same formula, only minus here, is 15.62. So in your production factory, in your operation plan, your average will be, central line will be, what is the central line? This figure is the central line, control limit or central line, and upper one is, this is the upper control limit, and this is this figure is the lower control limit. This is all about developing a control chart. So আপনি এখন control chart develop করতে পারবেন আশা করা যায়. If you cannot, please watch this video once again, then it will be clear. Right? This is all about developing a control chart for variables. Development of control chart for variables. And then we are moving to another slide. And if you plot the deviations, then the figure will be like this. It is the central line, and it is these are the upper levels, these are the lowest levels. LCL, this is, sorry, lower control limits and upper control limits. This is the lower control limits, upper control limits, and this is the average or center line. The indications are given here. And then the problem, another problem. Can you look at the problem? If there is any problem, then we can explain. This is an example of developing control chart using previous formula. This is the average or double X bar, means average of the sample averages. This is the average of sample number 1. This is the average sample 2, sample 3. There are 10 samples, and observations are 4 for each sample. 1, 2, 3, 4 observations. For sample 2, 4 observations. For sample 3, 4 observations. Sample 4, 4 observations. So average of sample 1 is 12.52. Average of, in our previous case, it was in vertical calculations, but now here it shows in horizontal way, because the number of samples are many. It is the very good system to arrange this observations. So sample 1, sample 2 average, sample 3 average, and total average is 125. So X double bar means 125 divided by number of samples. How many samples are here? 10 samples. So average of the averages. Average of the average sample values is 12.5 ounces, and the control limits, the information here, it says 2 ounces. Also standard deviation is 0.2 ounces. Standard deviation বেশি ভালো না কম ভালো বলেন তো?
স্যার কম ভালো।
কম ভালো
কম ভালো, কারণ কি যে আপনার তাহলে আপনার ভুলগুলি কম, তার মানে আপনার ডেভিয়েশনস কম। So 0.2, and also uses 3 sigma, 6 sigma. This 3 sigma means 6 sigma distribution of variables. So x double bar 12 and 3 is the z value, and standard deviation 0.2 divided by root over 4. 4 means here observations. Number 1, number 2, number 3, number 4. 4, and the upper control limit is 12.8 and lower control limit is 12.2. So you have to take care of this formula. G sigma x bar. The sigma x bar means the deviations of these observations. Average deviations of these observations. So here this is ultimately the standard deviations of the company that we are using to develop the standard deviations for the samples. So upper control limit is 12.8 and lower control limit is 12.20 here. So practice this type of problem from the book. There are some problems given there in the book. This figure is also taken from there. And control limit for range. Now come to the range. Control limit for range. Here the issue is more simple. This type of tables usually available for the reference. You do not need to develop this type of tables. This is known as factors for 3 sigma control limits. This is factors for 3 sigma control limits. Just you need to know how to calculate the average range. Can you remember this 0.2, 0.3 and 0.2? Go to our previous example, this one. This is our examples that we are following. The sample range is 0.2, 0.3 and 0.2. So we are calculating the average of 0.2, 0.3 and 0.2. We are calculating the average of 0.2, 0.3 and 0.2. So here 0.2, 0.3, 0.2 divided by 3. Total 1 range, 2 range, 3 range divided by 3 equals 0.22. Average R bar. This is known as the R bar. So you can use upper control limit range, lower control limit range using D4 R bar, D3 R bar. So our sample size is 4. In our case, what is the number of observations? Observation size is 4 and the D4 value is 2.28. So we are taking D4 value 2.28. D4 doesn't mean number of sample. You will use from your information 2.28 and multiplied by R bar. 0.53 is the upper control limit. Lower control limit is D3 multiplied by 2.33. D3 is for here, D3 is 0. D3 is 0, isn't it? So lower control limit is 0. So central line here is what is the central line? Central line, upper control limit, and this is the lower control limit. Lower control limit. This is all about developing a control chart using range or range bar. Range or range bar. And then move to the next section. I hope you are getting the points, and this is the plotting of the R bar information. Control chart. So there are 2 issues we have. One is control chart for variables. Control chart for variables is over. Now control chart for attributes. That means counting issues. Attributes. P chart and C chart. The charts are used for control chart development for attributes. Attributes are discrete events, yes, no. pass fail, this type, these are the examples of attributes. Yes, no, pass fail, etc. So use P chart for quality characteristics that are discrete and involve yes, no, bad, good decisions. P chart is applicable for yes, no, bad, good decisions. So whether you pass the exam or not, whether your result is good or not, this type of decisions are usually referred to P chart. P chart. And see the number of leak tubes in a box of 48. So there is a 48 tubes in a box. So number of leak tubes is when you will use this type of issues, then you will feature number of broken eggs in a carton. So broken eggs, you can count, leaking tubes, you can count. This type of issues are there for P chart. And for C chart, for discrete defects, when there can be more than one defect per unit. Number of flows or stains in a carpet sample cut from a production run. So defect calculation. Number of complaints per customer at a hotel. So this is also a comparative analysis. Complaints per customer. For this type of analysis, you can use C chart. Please read the book for better understanding. Due to time limitations, we are going speedily. However, you can watch the video, number one. Number two is that you can read the book. Book is very simple. The book, I have chosen the rates book because explanation is given in a very simple way. But in Stevenson's book is little bit difficult to understand the issues, sequences. I read all the books, but the Stevenson one is little bit difficult. That's why I have suggested you for rates book. It has described in very simple way. The examples are given in very simple manner. Now, come to the examples of P chart. A production manager. So, what type of when you will use P chart? This example may make you more clear. A production manager for a tire company has inspected the number of defective tires in 5 random samples with 20 tires in each sample. The table below shows the number of defective tires in each sample of 20 tires. Calculate the control limits. So your job is to calculate the control limits. Number of defective tires 3, 2, 1, 2. And the sample number 1, 2, 3, 4. And number of tires in each sample 3 out of 20, 2 out of 20, 1 out of 20, 2 out of 20, 2 out of 20. These are the 5 samples and these are the defect numbers and these are the total observations in the sample. So what is the control limit? Here we use P bar. P bar means 9 divided by 100. Total observation is 100 and 9s are defective. So 9 divided by 100 equals P bar. And standard deviation of P bar multiplied by 1 minus P bar. That means P bar is 9% and 91% is 1 minus P bar. 9% is multiplied by 1 minus P bar or 1 minus 0.9, 9% equals 91%. 0.09 multiplied by 0.91. 9% and 91% divided by total number of observations. So observations are 20. So multiplied divided by 20, we get 0.64 as the standard deviation. 0.64 as the standard deviation. And to calculate the upper control limit, we again will use 3 sigma. If it is not stated even, you will use 3 sigma. Please remember, Z value means 3. Even it is not stated. So P bar plus Z sigma. 9%. P bar is 9% plus 3. Standard deviation of P is 0.64. Upper control limit is 0.282. And for lower control limit, just use the minus 0.10. So minus lower control limit, you cannot use the minus in lower control limit set, you will use 0. Minus value means 0. So it is the range 0 to 0.282, and the central line is 0.09. Upper control limit is, this is central line CL. This is the upper control limit UCL, and this is the lower control limit LCL.
Sir, I have a question. Sir, যে sigma যে 0.064 স্যার এটা কোয়েশ্চেনে দেওয়া থাকবে না?
No, you have to calculate sigma P.
স্যার sigma P তো 0.64 but sigma তো এখানে 0.064. So there is a confusion.
Oh, maybe it is 0.64. Oh yes.
Oh,
You have got it there.
okay.
And then you will use this one.
Oh, okay,
Okay.
sir. Okay. আচ্ছা, আর স্যার
Oh,
Z
either
এর
this will be
কোয়েশ্চেনে
0.6.
দেওয়া থাকবে, right?
Sorry?
Z এর ভ্যালু তো কোয়েশ্চেনে দেওয়া থাকবে।
Z means 3. If it is not said, it is 3.
Sir,
Okay,
always.
6 sigma. It is always 3. And if we state that 2 sigma, then we'll tell that it is 2 sigma.
আর যদি কিছু না বলে সবসময় Z3 হবে।
3, always 3.
আর স্যার এটা কি 0.64 হবে না 0.064 হবে?
0.06, maybe can you calculate it? What's the value here?
ওকে স্যার, করে বলছি।
0.09 multiplied.
ক্যালকুলেট করে।
দেখেন তো।
স্যার 0.064
0. So it is 0.064. It is typo.
Yes, sir. 0.064 আসে।
0.64. So it is typo. So you have to calculate this value, okay? This sigma means sigma P. This means sigma P. These are the simple type of mistakes, but you are getting the points, I think. Sigma P, okay? P plus G sigma P, okay? Then
Yes, sir.
you
Yes,
can,
sir. Thank you, sir.
okay, so we can use P chart for this type of issues and C chart. Go to the C chart. C chart. This is similar type of example you can calculate from here. Here the issues are used properly. Sigma P, and sigma P. It is the value of sigma P multiplied by 0.042. Okay, this have used properly. And C chart. This C chart is about you can use this type of C chart when the problem is like this: number of complaints per week, number of complaints second week, number of this 3 means second subsequent weeks, 4th week, 5th week, 6th week, 7th week. So these are the complaints you have received over the time. And a control line means campaign divided by a total number of samples. Here, these are the samples. Week 10, 2.2. Total complaints divided by total week. So complaint per week on average is 2.2. 2.2. And you can calculate the upper control limit G root over C bar. Root over C bar. So here 2.2 is the and plus 3 sigma C bar. C bar means this one. 2.2. G bar means this one. And you have to use a root over after 3, and then this is the upper control limit, and you use this formula. This is the lower control limit, means minus when there will be a minus, you'll use 0 as the lower control
Sir,
limit.
C barটা হচ্ছে control limitটা, তাই না?
Control limit, average.
আচ্ছা, ঠিক আছে। Thank you.
Average is 22 divided by 10 is the average. And this 10 means 10 weeks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. We can count week number 1, second week, third week, fourth week, but you will use the number of weeks. 10 is the number of weeks. All right. So as usual, how you calculate the averages? This is also simple average. 22 total complaints divided by time period, 10 weeks. This is the per week, average per week, is it? All right. Writing using mouse is difficult. So 2.2 average complaints per week. So you are calculating the upper control limit and lower control limit for the complaint per week. It is the, maybe you can receive 6 complaints, 7 complaints, all right, and you may not receive any complaint in a week. Upper control limit and lower control limit. This is all about control chart development. We have skipped many things of the chapter. Considering the issues, you will just review this chapter, these issues only from the book. Please read the book. That is very important. All right. But about the other chapters, maybe the chapters are very easy. If you cannot stop recording is better.
Sir, formula